that I did for Miss Hollister, I did find out what was wrong right after class ended. I did it and I saw exactly what happened. I assumed, and it was my fault, most questions that have to deal with age and years. Let me pull that question up right quick. Miss Hollister, I think it was this one. Let me see. It might have been this one. Yeah. Most of the time when you're dealing with a year or you're dealing with an age, sometimes they say years from the age of 67 or years from 1962. Okay, and I was assuming, if you'll remember, I saved the problem. I did this. You remember me doing this right here? Do you remember me doing that? Putting a 0 under it? Most questions, when you're dealing with years and ages, wants you to use 0, but this one did not specify that, so they don't want you to use 0. They want you to use the age. So this point right there is 77, 2620. And when you plug those two numbers in, you get the answer. I plugged in 0 instead of 77. And like I said, most of the time, they want you to do that. And when you do that, here it is. So write that down for that problem, because that problem, and that, let me give you that problem again. That was 1.4 53/19. 1.4 53/19. There's the question, and this is the answer. So I wanted to fix that before we got started on the other questions, because we got some more questions and we got some from the review, which is good, because some of you forget some of that stuff. So, and then we're going to move into 2.2. Okay, hopefully y'all got that written down. And if they ask you to, what if, let's see, write the linear function. Well, that's the linear function right there. And then what monthly benefit would you anticipate at 70? So you would type in 70 for X. And that would be 70. Well, turn it on. Clear. 130 times 70 minus 7390. So that check would be 1710. Okay, so that's that question. And it was my fault. I just assumed that it was one of those questions, but unless it has that sentence in there that says years since, okay, it says right here, okay, the starting age is, oh, I'm sorry, somewhere it says 67. In this case, it was 67. I did one as 77. I'm sorry. Hold on. I got the 67 in here somewhere. There's 67. Sorry. This is 67. I think I did two questions. There's 67. So that would be 170 times, and what are they asking? 70. And the minus 9860. So that would be 2040 on that question. I'm sorry. For some reason, when I pulled it up, one said 77, and this one said 67. So I don't know what I did. I must have hit similar question or something. Okay. All right. Sorry about that confusion on that question. Now, we got some questions. I'm going to delete that one. And we did that one, I think. Let me delete this one. And this one, I think we did. Let's check. Is that the same one? I think it's the same one. Yeah. There's the 77. So I showed you the 77 a while ago. That's why I pulled up both questions. So there's both of them. So whoever sent this question, Miss Hayden, I showed you that one. That was the previous one I showed you. So you would use 77 instead of 0. Okay, that takes care of that one. So let's see what kind of questions we got on these. So this is, I'm going to do these review questions first. I don't know if, so let's see, this is 2AT 51. So I don't know what AT stands for, but this is the skills review homework, integrated review, number 18. So this is like number 18 in your homework for that 2AT, I think, second skills review. Let's see what it looks like. Okay, that's an inequality. Now, let me go over inequalities right quick, because anything that I think is important and we go over it in a review, I'm going to explain it a little bit more. So let's go over inequalities. First of all, you got to remember these two guys are going to give you a closed circle in brackets and a solid line if you're graphing. These two guys are going to give you an open circle, parentheses, or a dashed line. So you got to make sure you understand that first. Okay? Also, I give my students, when I teach Algebra 1 and Algebra 2, 101, 102, whatever the case may be, I tell students to keep life simple. You always want to try to keep the variable positive. Now, you're not going to be able to do it all the time, but 99% of the time, you want, I'm going to put that in red. And, I don't like to write in red. Try to keep variable positive. Anybody know why? Well, it makes life easier on you because you don't have to remember the divide through by negative rule, which you have to flip the inequality. Okay? I'm going to put that under there, and I'm going to put it in blue. if you divide or multiply through THR through by a negative, you flip the inequality. Okay, that's why you forget to do that, and you only have to do that 1% of the time. So if you remember to keep the variable positive, you don't have to remember this unless you have to do it. And I'll show you, here's an example of when you have to do it. -4 less than -x less than 8. That is an example of when you have to use this rule. That's why I put it in blue. Divide by -1, divide by -1, divide by -1. X, and then you have to flip -8 and 4. Okay, that is why I tell you to keep the variable positive so you don't have to worry about this. Now, 1% of your questions will be like this, and you can't do anything about it. But the other 99%, you're going to try to keep the variable positive. Okay. Now, I like to keep things simple, and if you want to play, flip the inequality, knock yourself out. But I'm not going to teach it that way. I'm going to teach it 99%. I'm going to try to keep the variable positive. So with that being said, on inequalities, I'm going to do this problem. So -2 x minus 7 less than -7. First thing I'm going to do is distribute this 2, and I get -2x plus 14 is less than -7. And I'm going to bring that 2x across the river and bring that 7 across the river. And I get 21 less than 2x, divide by 2, x is greater than 21 over 2. That's your answer. Always graph it. Whenever you do an inequality, you always graph it so you can determine the solution set. This arrowhead's called negative infinity. This arrowhead's called positive infinity. Zero's in the middle, and this is 21 halves is 10 and a half. So I'm going to put 10 and a half right here, 21 halves, and I'm going to put an open circle. And what numbers are larger than 21 halves? Everything to the right. That encompasses positive infinity. So interval notation is what I use. So your answer is parentheses 21 halves, comma, infinity. That's interval notation. And that's your answer. I don't know what they want, but that's the answer. That's the solution set. That's how you graph it. And that is interval notation. So it says over here, solve the inequality. X is greater than, hold on, where's my drawing? Greater than 21 halves. Now, there's going to be some of y'all out there that's going to be going, oh my God, he put the variable on the right side of the parentheses or the right side of the inequality. There's nothing that says you can't do that. I love those people that are taught that. They need to go back and hit their teacher in the mouth. Why? Because let's say that you live in Anderson and you take your kids to the park and there is a seesaw and you have two kids. Your kids' name are Jody and Susie. And Jody gets on the left. You're sitting here looking at the seesaw, and Jody gets on one side of the seesaw, and Susie gets on the other. Okay, Jody gets on the left side, and Susie gets on the right. Then you go over to your sister's house, who lives in Star. And she has a seesaw in her backyard. And all the kids go out, and you're standing there looking at that seesaw. And Susie gets on the left-hand side, and Jody gets on the right-hand side, and you have a fit because Jody is supposed to sit on the left-hand side. How ridiculous is that? Very ridiculous. Okay? The equal sign is the fulcrum. It doesn't matter where you put the variable. Only you have been programmed that the variable goes on the left-hand side. The variable can go on either side. You have just been programmed to put it on the left-hand side. Some of y'all are going, I've been programmed. Yes, you have. You didn't know you were programmed, did you? So, hopefully that's a good test question. I wouldn't mind putting that on the test as a review question. But anyway, always graph on the number line so you know what the solution set means. Next question. This is 2, 5. So this is number 3 on your review homework. Find the following quotient and write the answer in lowest terms. So I'm glad to see this because a lot of people forget how to do fractions. And I'm glad you sent it because I guarantee you there's 3 or 4 more students out there, if not more, that need to know how to do this. And I'm going to go through and give you addition and subtraction. You got to have a common denominator. So if I give you 1/3 plus 3/7, then you have to have a common denominator of 21. And you convert. 3 will go into 21 7 times. 7 times 1 is 7. 7 will go into 21 3 times. 3 times 3 is 9. 7 plus 9 is 16 over 21. That's how you add and subtract. Multiplication and division. Well, multiplication of fractions, you either do it and reduce, or reduce and do it. So let me give you 1/2 times 4/3. Well, you can either do it 4, 6, and then 2/3 and reduce it. Do it and reduce it, or you can reduce and do it. However you want to do it is up to you. And that's how you multiply fractions. Division of fraction, there is no such thing. When you divide by a fraction, you multiply by the reciprocal. So if I give you 1/4 divided by 3/2, well, that's not, there is no division. You change it. You say 1/4 multiplied by 2/3. You multiply by the reciprocal. And that's going to give you, you can do it and reduce, or you can reduce and do it. Okay, so that's a little review on fractions. Now this problem says 16 over 21. I'll just do it down here since we're dividing. So 16 over 21 divided by 4 over 7. So I take my red pen and I just mark that division out because you can't do division by fractions. You rewrite it, 16 over 21 multiplied by 7 over 4. And we can do some canceling here, or you could do the long way and do it and reduce, but I'm not going to do that. 7 will go into 7 one time, 7 will go into 21 3 times. 4 will go into 4 one time, 4 will go into 16 4 times. So your answer is 4/3. 4 times 1 is 4, 3 times 1 is 3. Now, Hubert, why don't you change it into a mixed number? Mixed numbers are only used for units of measurement. This one's not asking for a unit of measurement. This is asking for an answer. So 4/3. And I guarantee you, whoever sent this question, there's probably several others that forgot how to multiply by the reciprocal. Next. Number 1 on the homework of the skills review. 2AT1, number 1. Again, there's our multiplication. So this one you can do. So it's going to be 35 over 36 multiplied by 4 over 7. And you could do it, you could go through and multiply 35 times 4 and 36 times 7. I'm not going to do that because that takes more time and you have to depend on the calculator. 7 will go into 7 one time. 7 will go into 35 5 times. 4 will go into 4 one time. 4 will go into 36 9 times. 5 times 1 is 5. And 9 times 1 is 9. So your answer is 5/9. And we feel good about ourselves. 2.1, 41. Let me make sure these are in order. Subject. Okay, 2.1, 51, 51. Got another review, so let's do this one. This one is number 20 on your homework for the review. Indicate the number of significant digits. Okay, remember, only thing you got to remember on significant digits is something my professor at Clemson told me a long time ago. Zeros are good if they hold a place. You've got two zeros in between two numbers. Is this the same as this? No. So therefore, if the answer is no, then these two zeros are placeholders. And if they're placeholders, that equals their sig figs. And of course, 2 and 6 is sig figs. So in this case, the answer would be 4 significant digits. What would be an example of not? Well, that would be 24.00. This is equal to significant digits because the zeros are not good. The zeros are useless. If a zero or a number is useless, and usually it's 0, if 0 is useless, what in the world are you opening, Miss Hollister? You eating breakfast? Now she's not going to say anything. Oh, somebody chatted something. What are you chatting? Oh, I thought so that was new. Sorry. Okay, so that should answer. So let's see if I'm right. 4. Ding. That's not a test question, but you're going to see that on in other classes, especially chemistry and physics and biology. Okay, so that takes care of that one. So now we got 3 questions, 41, 51, 251. So that question is the same. All right, this is 2-1-41-12. First of all, is it a test question? Oh, yeah. So we got to solve. Now, first of all, we're going to write something down about these formulas. And I do this when I teach 101 and 102. I ain't taught it in years because it's in another department. But when I did teach it, I always told students these 2 things about formulas. This is red, so this is important. Number 1, always clear fractions and decimals when you can. That's number 1. I'm sorry. Always clear fractions or decimals when you can before you get started. I'll give you an example of that in just a second. Number 2, capital letters do not equal lowercase. And you should know that from your high school science classes. I would never change this D into a lowercase d. I would never change this uppercase G to a lowercase g, and I would not change that R to a capital R or that T to a capital T. Because in science, little t means what? Anybody know? Time. What does big T mean in science? Temperature. Little r usually means radius. Okay. D, big D, could mean diameter, but I'm just, talking. But usually the directions or the unit or the context of the formula will tell you what's what. Now, Now that I've established there's no fractions and there's no problem with the capital or lowercase, I don't have any problem with that. Now I can look to see what to solve for. They want you to solve for little t. Well, the first thing I got to do is get that t separated because that's a cement block with a ring in it. And if you have ever worked with concrete before, if you drop your ring into concrete and it cures, you got to take a big hammer and bust it up. Well, the distributive law is the hammer, and it busts up the big block. So you can actually get to the t. So that's going to be G is equal to D plus dRt. And now I'm going to get rid of D. So I'm going to subtract D. G minus D is equal to dRt. And how do you get rid of multiplying by dr? You divide by dr. So T is equal to G minus D over dr. Now, what if you had this? A is equal to 1/2 base times height, and you want to solve for h. Well, the first thing you do is multiply both sides by 2. Why? Because that's the common denominator of 1/2. So I'm going to multiply both sides by 2, and that's going to give me 2a is equal to, well, that 2 and that 1/2 cancel. And now you're left with BH and divide by B. And H is equal to 2A divided by B. And that is a little review on solving for formulas. So glad you sent that, because like I said, if you sent it, chances are there's about 2 or 3 others in the class that sent it, because not everybody can invent mathematics. So I've got brackets, and I'm going to put G minus D on top. So G minus D over dr. D times R. I may need to put, I don't know if I need to put that there. So I think that's it. I feel good about myself. How are we doing? Everybody doing okay? Y'all not very talkative today. Okay. No, Hubert, we don't feel like talking today. It's cloudy. Okay, I understand. Yeah, it's cloudy here too. Some of y'all are calling from BFE, so y'all probably sunny and warm and not cloudy. Yeah, pretty much, Hubert. Thank you for being an interactive class. I appreciate it. Boy, y'all are hostile today. Why are y'all so mean? I heard a breath. That's good. Oh my God. Was that a laugh? All right. Next. This is 2.151, question 16. A building is worth 800. Well, we did this, but we'll do it again. A building is worth $825,000. It is depreciated for tax purposes by its owner using the straight line depreciation method. The value of the building, Y, after X months of use is given by, there's the formula. I'm going to write that formula down. So Y is equal to negative 2200X plus 825,000. Okay. Okay. Y after X months of using it. Okay. So when will it equal 693,000? Well, then you set Y equal to 693,000. So 693,000 is equal to negative 2200X plus 825,000. All right, I'm going to give you a minute, and I want you to solve that for X. So I'm going to turn the stopwatch on because I want to discourage you as much as possible. So I figure if I time you, that will freak you out even more. So let's go. So solve that equation for X. I got to fill my vodka back up. Okay, that's a minute. So I'm going to subtract 825,000. Subtract 825,000. Take my handy dandy calculator because I suck at subtraction. And that's going to be 693,000 minus 825,000. Did I write that down right? I guess so. Minus 825,000. And that's going to equal negative 132,000. Negative 132,000 is equal to negative 2200X. Divide by negative 2200. Divide by negative 2200. Divide by negative 2200. And 60. X is equal to 60 months. So in 60 months, I guess that's what they want. See, okay, years. So 60 divided by 12 would be 5 years, wouldn't it? Divided by 12, I'm just doing it off the top of my head. Yeah, dang old 5 years. Excellent. And you should feel good about yourself. So that's 5 years. So let's do the last one for good measure. I think this is the same one. All right, you try that one. This is a little bit different. So go ahead and try that one. I'm going to give you 3 minutes to do it. And if you can't do it in 3 minutes, and we all know what that means, that pretty much means it's your failure. There you go. Okay. Well, that's 2.5 minutes. That's close enough. So we're going to set equal to 669,400. 669,400 is equal to negative 2,300 plus 835,000 minus 835,000 So take our handy dandy calculator, and 669,400 minus 835 and divide by 2,300. So when you do the math, you get x is equal to 72. Okay? And 72 is like 6 years. So that would be 6 years. And hopefully you feel good about yourself. And that is the questions for today. Now what are we going to do? Well, I'm going to fly through the next section, so hopefully you won't get it and be discouraged all weekend because you can't do the homework. So what we're going to do is go over the next section, which is, what was it? What chapter are we in? 2? I can't remember now. Section 2. And section 2 is about using the calculator in the Excel spreadsheet. Okay? I am not going to try to get you to do this by hand. Does everybody understand that? It's called the line of regression. And you don't want to even think about doing it by hand. Does everybody know what that's called? Anybody want to take a guess? What is that called?
A scatter plot.
A what?
A scatter plot.
Good job. Scatter plot. Very important because this is how you get a line of regression. All right. Now, the mathematics is very tedious. That's why I don't want you to do it by hand. And the book shows you a lot of technology because they don't want you to do it by hand. All right. Thank goodness. This is one section. Thank goodness for the calculator and the Excel spreadsheet. So with that being said, finding a line that fits these dots is what you're going to be doing. And that's called the line of best fit. Okay. So that has a slight upward Correlation. I don't think we're going to get into correlation and causality in this class, but you should be able to do a line of regression. Line of regression. You should be able to tell me what the equation of that line is. And you should be able to tell me, well, it's also called the line of best fit. And you should be able to predict this point way out here based on this line of regression. Okay, so that's what this section is, and that's what I'm going to test you on. You can do this on the Excel spreadsheet. I don't know if that's the way you spell it. I don't know if there's a C in there or not. Or you can do it on the calculator. And you can do it on StatCrunch, but I don't know if they give you that in this 109 class. So we'll look at it and see when we do a homework problem. Well, let me just go to the homework. I can't remember what chapter this is. For some reason, I blanked. What chapter is it? 9? That's trig. 2. 2.2, is we in chapter 2? Is that where we are? Yeah, Hubert. No, Hubert. You have no idea what you're talking about, Hubert. Okay, thank you, class. Appreciate the interaction. It's always good to have a class that interacts. Makes the class go by a whole lot faster. Right? Yep, it does. Yeah, 2.2. So I'm going to click on, I'm just going to click on one of the, let's see, chapter contents. Where's chapter contents on this book? Or is it called e-text contents? Is that what it's called? 2.2 and study plan. Because I'm just going to show you how to do it on both the Excel spreadsheet and the calculator. So once I find a good test question in the study plan, I'll tell you this is what 2.2 is. Okay, is this a straight line? I hope it's not. 2, 1, 4, 5. Well, this is good as any. All right, I want you to write this problem, or just write the chart down. Okay. Construct a scatter plot of the data in the table. If you want to go ahead and type it in your calculator, you can do that also. If you don't know how, I will show you in just a minute. Well, I'll show you right now because I'm just going to copy it. If you hit this little tab right here, it will send it to the Excel spreadsheet. And I'll do that in just a minute. But right now, I'm going to type it in the calculator. For those of you that don't know, and I don't know how many of you were on the calculator drill team in high school or was not on the calculator drill team, but hit Stat and Edit, Enter. And there is your spreadsheet. And now you just type X in 2, 4, 6, 8, 10, 12, 14. Now you type in 1, 5, 7, 9, 11, 13, and 15. Now you type, if you wanted to do a scatter plot, you hit second, y is equal. See the stat plot up there? And you hit enter, and there's the scatter plot. It's defaulted to scatter plot. Hit on, and now just hit, it defaults to L1 and L2, and to the scatter plot, and you hit graph. Now you may not be able to see it clearly, so I would probably hit zoom. I'm sorry, wrong button. And go down to, I think it's 0 for stat, or 9. Zoom stat. There's your scatter plot. Now, sometimes it'll be linear, sometimes it'll be all over the place. Now, how do we find a line of regression? Well, that's where you hit Stat, Calculate, and number 4, Linear Regression. Hit Enter. It automatically defaults to L1 and L2. All you have to hit is Calculate. Now, for this problem, it gives you y is equal to ax plus b. Well, nobody writes it like that. Y equals mx plus b. And a is m, so that's going to be y is equal to 1.107142.857 x plus, it gives you b, negative 0.1428571429. Okay, so your final answer is y is equal to 1.107142.857x minus 0.1428571429. Now, of course, you round accordingly by the instructions, but that's what the formula, that's what the equation of the line looks like that goes through those points. Now you can take your handy dandy calculator and you can type that in. Y is equal to 1.107142.857x. Don't hit the X key, you got to go up here. Oh, you got to hit that X. Minus 0.1428571429 and hit graph. And there is the best line to fit between the two, between the points. Okay. Now it also gives you an R. R is what we call the correlation coefficient. The correlation coefficient is going to be between -1 and +1. Correlation coefficient. Correlation is related to slope. If you have a positive slope, which we do, you're going to have a positive correlation. If you have a negative slope, you're going to have a negative correlation. So that's the relationship. The difference between slope and correlation coefficient only goes from -1 to +1. Slope goes to any number. It can be any number, any fraction, any decimal, it can be anything. But the correlation of positive and negative is the relationship between slope and the correlation coefficient. So in this case, we know that it's positive, but what is the correlation coefficient? Well, go back to Stat, Calculate, Linear Regression, and hit Calculate. Now, if yours don't show, it has to be on Diagnostic On to show the R squared and the R. So R is 0.9923. 0.9923. So that is a very strong correlation. Very strong correlation. Positive correlation. Now, what does that mean? That means that there's a pattern in the dots. Does it mean that something causes something else? No. Okay, that's called causality, and we're not going to get into that here. But it has a strong correlation. Oops, can't see all my writing, I'm sorry. Okay. Now this is what we're going to be doing in 2.2. You're going to be drawing a scatter plot. You're going to be finding the correlation coefficient, and you're going to be finding the equation of the line. Luckily, you don't have to do it by hand. You're going to do it by the calculator, which I just showed you, or you're going to do it by the Excel spreadsheet. So let's do it with the Excel spreadsheet now. Open in Excel. And there's our points. Highlight the points. Go to Insert. And there is your scatter plot. So to draw your scatter plot, you just highlight the 2 rows, 2 columns. You go to Insert, and you pick which one you want. In this case, the scatter plot. Now what? Now you got to find your trend line. In Excel, it's called trend line. In statistics, it's called regression line. Right-click on one of the dots. Go down to Add Trend Line. It will read it as much as it can. In this case, it's going to be linear because the computer suggests that it's linear. And you go down to the bottom and you put display R squared and display equation. And of course, that can be fixed to where it's a little bit bigger. And there is your, now you got to take the square root of R squared. So take your handy dandy calculator and go 0.9846 raised to the 0.5 power. And there is the number 9923 that we got for our first one with the calculator. Now, with that calculation, you can actually say to yourself, well, what if I wanted to go to 16 instead of 14? Well, with that line, you could calculate that number with 16. You plug in 16 for X, and you would calculate that Y at 16. X is equal to 16. And that's what the trend line is used for. And I bet you didn't even know you could do that, but you can. Of course, the calculator drill team knew it because they've been using the calculator for the last 13 years. They've been going to school for 12 years. Okay? So let's try another one. Anybody got a question so far? Y'all settle down, please. Y'all gonna have to settle down. She's too loud in here. Are y'all like this with your other classes? How are your other classes? How are all your techno-savvy teachers doing?
Good.
They are?
I'm sorry, what?
I said, how are all your tech-savvy teachers doing? I'm saying that sarcastically because I know there's some that don't know how to use any technology. I just wondered if you had any stories to tell me.
No, I mean, that's fun.
That gum.
Yours is my quiet class, though. Your class is pretty quiet. I'll give you that.
My class is the quietest?
Yeah.
Why is that?
I don't know.
So you have, other Mr. Abdallah, how many classes do you have the same format as mine?
I mean, it's all like this. It's not Microsoft Teams, if that's what you mean, but it's just like this.
And y'all talk in other classes?
Not as much, but more than this.
Why? What does the teacher do different?
I don't know. I think it's just because of your math. So,
You
I don't
think
know.
it's because it's math?
Yeah, actually, in fact, while we're here, I might have to leave class like 5 minutes early. Will that be okay?
I don't care. But
Okay,
just
good.
make sure somebody tells me that you were here when I take were you here Tuesday?
I was, yeah.
Okay, well, don't worry about it then.
All right.
Because you already counted present for this week.
Oh, okay.
Okay.
Cool.
Well, I just wondered if it was something about my class, because y'all just quit talking. So, all right. So we know it's either this one or this one. I'm going to go with A. I may be wrong, so it must be D. And you have to look at the dots and see if you see which one is, that's just matching up the calculator or the Excel spreadsheet with their drawing. Okay, now let's look at, let's see, it says round to the nearest what? Round to 3 decimal places. So I'm going to take my handy dandy one right here, and I'm going to go, well, 1.107. And here is going to be 0.143, negative 0.143. Okay, there's probably a rounding error. Let me check. It says round to 3 decimal places. 107. I don't know what the problem could be. Whoa, wait a minute. I've done something wrong. Correct answer is 2. Wait a minute. How can they get a positive? And I'm supposed to, wait a minute. How? I've got a positive slope. Okay, did they do something that I'm not aware of here? Hold on a second. Write a linear model for the data in the table. Okay, I did what I was supposed to. I don't understand where they get. Let me see what they're doing, because they might be just pulling 2 points and finding the slope. They might be pulling, I bet that's what they're doing. They're pulling the first point and the last point. Let me see what they're doing. Okay, this one don't have, oh, this is one of those stupid questions that don't have. Let's see if that's what they're doing. 2 and 5 and 16 and 27. I bet you $1 this is what they're doing. And that's going to be M is equal to 27 minus 5 over 16 minus 2. This is kind of like the old way of doing it, using the first and the last point. And that's going to be 27 minus 5 is 22. And 16 minus 2 is 14. And that's going to be 11 over 7. And 11 over 7, 11 divided by 7, 1.5. That's what they're doing. They're using points. They're using the first and the last point. Now I'm a little bit off. They got 1.570. I got 1.571. Okay, and then they're doing y minus 5 is equal to 1.571 times x minus 2. And that's going to be y minus 5 is equal to 1.571x, and multiply that by 2 minus 3.143, and then y is equal to 1.571x minus 3.143 plus 5. So we're going to add 5 to that. Oh, that's a minus, isn't it? So negative second answer in plus 5, 1.857. See, they got 2.09. I think what they're doing is they're picking 2 points and they're getting a rough estimate. I've got the more detailed with the calculator and the, so 1.857. But I don't know how they are doing that without telling you what points to pick, because you could pick any of these points, right? A linear model for the data in the table. Okay, I'm just going to say this could be variant answers because they're not telling you which numbers to pick. So I have no idea how they're getting this without churning out they're picking 2 of these points. Let's see. Let's look at the data again. Let's go down here and pull up the Excel spreadsheet. Where'd it go? Did I lose it? I must have lost it. Okay. Let me pull up the Excel spreadsheet. I'm a little bit confused. I wonder why it don't have help me solve this on it too. That sucks. Okay, Excel spreadsheet. Come on. It's not doing it. Okay, so I won't do the Excel spreadsheet. So let me go look at the, where is the, didn't it ask us what it looked like? Okay, I guess it's not. Okay, I thought it asked us what the graph looked like. Did it not? Okay, y'all not going to talk to me, so. Did anybody see, did it ask what the graph looked like? Yes or no?
This is a different question now.
Okay, it is a different question. Okay. Well, I'm going to be honest with you. I would have to go through and do the math since it doesn't have a guide on it. Let me look and see what the textbook. They're picking a certain 2 points. Whatever. This question is screwed up. It doesn't have an ask me. It doesn't have anything. It doesn't have, and then it says, okay, it's going to take me to the book now. And there's something wrong with this question. I'm going to go to the next question. Let's go to another one. Okay, this one says determine which of the equations y is equal to blah, 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 or y is equal is better fit for these points. Okay, so let's do this one. And I'm going to go into my Excel spreadsheet, or we'll do it in the calculator, and go to Stat, Edit, and we're going to type these in. I'm going to clear. If you want to clear, you go to L2, hit clear, and hit enter. Do not use delete. If you use delete, you'll delete the whole column. So go up to L1, hit clear, and hit enter. And now I'm going to type in 0, 1, 2, 3. 1, 2, 3. And then over here, I'm going to type in 4, 4, 3, 3. 4, 4, 3, 3. And we're going to plot it. So go ahead and hit stat, or go ahead and hit second, stat plot, on, and graph. Okay, I'm going to clear that other thing out. Let me clear that out. Now hit graph, hit zoom 9. There's not much correlation there, so you're going to have a line going like 45-degree angles up through here. So I'm going to go to stat, calculate, first variable, linear regression, and calculate. So I get, as a best line fit, I don't know what they're doing, but I get y is equal to negative 0.4x plus 4.1, and I got a correlation coefficient of negative 0.8944, which means I have a strong negative correlation. So that 0.4, this is the line of best fit. And they got nothing that looks like what we got. They got one right here that's pretty close. So I would go with this one. I would go with B. I'm going to have to do some research and find out what they are actually doing, because it looks like to me that they're picking a certain point, and I'm using technology, and it's not Jihan. One more, and I want you to do what I'm doing. So I'm going to have to find some questions that actually do what I'm doing. So here's the question, or we're going to put this in Excel. And I'm going to pull this up. And now Excel worked on this one, didn't work on the other one. And I'm going to highlight these, go to Insert, and Box Plot. It's somewhat linear, but it's not exactly linear. So I'm going to right click and hit Add Trend Line and hit R and Display. We'll move that over here, make it bigger. And this one, I'm going to write down, I get y is equal to 4.5x minus 0.1, and I have a correlation r squared equal to 0.9868, which is going to be a very strong correlation when you take that square root. So it looks like you got one below, above, below, above, below, above. So let's look at what their options are. Well, it's approximately linear. It's not exactly, because it's not a straight line. So I would say approximately linear. That's all they're going to ask? Okay. So you see that this is not a very difficult section. All right. I might want to warn you that some of the answers that you get by using the data will be a little bit off, but until I can figure out what the book is doing, we're going to just go ahead and go with what I'm showing you, okay? So that means on your homework, I want you to use the technology, and I don't know how many questions you got. Let's see how many questions you got in homework. Let's see, 2.2. Okay, I hadn't assigned it yet, so I'll go ahead and assign it right now. Instruction tools, assignment manager, 2.2, assign. There we go. Now hit assignment. Assignments 2.2. And you got 16. So I will check out and make sure, and we'll go over. Now, this is not too bad. That's a parabola. Okay. This is not a linear function. So those you can do. So go ahead and work on, you got 2.1 and 2.2 and the reviews to work on. And let me go ahead and look at the, turn this off and turn off the recording.